Hello and welcome to yet another video where we solve a problem to prepare for the GMAT. As usual, I'll give you a second to pause the video if you'd like to solve the problem yourself, and then we shall proceed to solve the problem together. Alright, so let's begin. Here we're given a series and we're asked to sum the series to n terms. We're given five different options, 4 of which are expressions for what the sum of the series to n terms might be, and the fifth which says none of the options above are correct. So there are different ways in which we can approach this problem. One way we can approach this problem is to try to solve it from first principles, to try to derive an expression that would denote the sum of the series, and then check which of these possibilities that are given to us is the correct answer. Another way of solving this would be to actually sum the series to 2 terms, to 3 terms, and so on, and then substitute n equals 1, n equals 2, n equals 3, and so on, and see which of these expressions actually gives us the correct answer and select that as the right answer to the problem. So now let's first solve this from first principles and see if we can derive an expression for what the sum of the series to n terms would be. Okay, so here Tn, or the nth term of a series, is given by n times n plus 2 times n plus 4, right? If n equal to 1, we get n is 1 times 1 plus 2 is 3 times 1 plus 4 is 5. So 1 times 3 times 5, which is the first term in the series. N equal to 2 gives us 2 times 2 plus 2 is 4, and 2 plus 4 is 6. 2 times 4 times 6, which is the second term of the series, and so on. So Tn is n times n plus 2 times n plus 4. We want to find the sum of Tn. So let's denote that as sigma Tn, or Sn is the sum of n terms of the series, where Tn is given by n times n plus 2 times n plus 4. So this is equal to the sum n times n plus 2 times n plus 4, right? This is the type of series we want the sum of the first n terms. If we expand it out, we get n squared plus 2n times n plus 4. Or we want the sum n cubed plus 2n squared plus 4n squared plus 8n. Or we want the sum of n cubed plus 6n squared plus 8n. That is the sum we want. Now we know from studying series that if we want the sum of the first n numbers, sigma n, that is given by the formula n times n plus 1 over 2. We also know that if we want the sum of the squares of the first n numbers, it's given by the formula n times n plus 1 times 2n plus 1 over 6. And that if we want the sum of the first n cubes, or sigma n cube, that is given by the square of the first formula of sigma n. So sigma n cubed is given by sigma n, the whole squared, which is n times n plus 1 over 2, the whole squared. We know these things from the formulas that we've studied for solving problems on series. So sigma n cubed here, so if we expand it out, we get sigma n cubed, everything in parentheses here, sigma n cubed plus sigma 6 sigma n squared plus 8 sigma n, right? Just carrying this sigma sign inside for summation. We know sigma n cubed from here on the left panel. We know that it's equal to n times n plus 1 over 2, the whole squared. We know that and sigma n squared is given by n times n plus 1 times 2n plus 1 over 6. That's convenient, the 6's cancel out. And we know that sigma n is given by n times n plus 1 over 2. Again, 2 and the 8, you get a 4. So simplifying this expression, let's go here to do the simplification. We then get n times n plus 1 over n squared times n plus 1 squared over 4, right? Because we're taking out the square, plus n times n plus 1 times 2n plus 1, because the 6 cancelled out, plus 4 times n plus 1. We're simplifying further, we get n times n plus 1. And then inside the parentheses, we get n times n plus 1 again, over 4, plus, and we have to be careful here to make sure that we do this right, plus 2n plus 1, plus 4. And if we expand this out, we get n times n plus 1 times n squared plus n plus 8n plus 4 plus 16 all over 4, which simplifies to n times n plus 1 times n squared plus 9n plus 20 divided by 4. And n squared plus 9n plus 20 factors as n plus 5 times n plus 4, right? So then we get n times n plus 1 times n plus 4 times n plus 5. Just going to draw that partition over there so we don't get confused. Divided by 4. That is the expression that we want. N times n plus 1 times n plus 4 times n plus 5 divided by 4. Now we see that none of these expressions here actually matches the expression that we got for the sum of the for the sum of the terms of the form in the series. None of these expressions matches, so the correct answer that we want is E. But we would be remiss in our responsibility of solving the problem right if we didn't check that this was actually the case. So let's compute out the first few terms and verify that it's actually true. So the first term evaluates to 15, the second term to 48, the third term to 105, right? So let's check what T2 and T3 are with our formula, right? N times n plus 1 times n plus 4 times n plus 5 divided by 4, where n is equal to 2. So that would be 2 times 2 plus 1 is 3, times n plus 4, that's 2 plus 4 is 6, times n plus 5, that's 2 plus 5, that's 7, divided by 4, right? So that's 9 times 7 is 63, which is equal to 15 plus 48, which are the first two terms, right? So we know that this works out correctly. What about T3? Well, n is 3, n plus 1 is 4, so 3 times 4, n plus 4 is 7, and n plus 5 is 8. So 3 times 4 times 7 times 8 divided by 4. That's 21 times 8. That is 168, which is equal to 105 plus 48 plus 15, right? 48 plus 15 is 63, 63 plus 105 is 168. This is correct. So the expression that we want is this one, and the answer that we want is E, none of the above. Thank you for watching.